Hi friends, in the last video, friction part 1, we learned about the definition of the friction, cause of the friction and relationship between the force and the friction. Now we will see how to measure it, what is the effect of the friction and whether the friction is good or bad in our day-to-day life. So let us concentrate on this topic. Oh, now let us try to measure friction. You can guys try this. Let us say you have this block, okay? And if you are applying the force, you apply a very tiny force. Let us say you are applying a very tiny force. Let us pull the chair instead of pushing. You are applying the force to pull the chair with the very tiny force. Will the chair move? No. Right? Do you agree, guys? Here it is not going to move. So it is who? Who is stopping it? Who is stopping the chair, guys? Friction. Right? Friction. There is a friction acting in this entire chair. Where is the friction acting? Whether it is acting here or here or here or there or where it is acting. Can you guys tell me? So here is the friction in this case. It is in opposite direction. But where? Very good. It is pulling the chair on the ground. It is on the ground, right? So you know it goes friction on the ground, right? It is actually on the four legs. Definitely there is a friction. So there is a friction on the legs, right? Friction is greater than the tiny force. So we are trying to pull it with the greater force than the tiny force. Because the force is very tiny. Okay. So let us see you are measuring the friction. In this case, the forces and friction are not equal. Friction is greater than the force. So you start with the little more force and the time will come the chair will get just starts to move. Do you guys agree? You keep increasing this force. Now it is nowhere if you keep increasing the force. Do all of you agree? The time will come, the chair will just start to move. And the chair just starts to move. The chair is just about to move. What is the relation between the force applied and the friction? Can you guys tell me? Can you guys tell me when just starting, just about to move? What is the relation? Can you guys tell me between the force and friction? Which one is greater? So relationship, I am asking, there is in opposite direction, but which one is greater? It is just about to move, which is not started, right? What can I say about that force pulling it, right? Pulling it, basically at pull, force is just equal to the friction. They are just equal because it just move. So there is a balance equal. Yes. So this means, can you say force is exactly equal to the friction at four legs of the chair? Right. So this will help us to measure the amount of friction because we have adjusted the force to be equal to the friction. So can you reverse this? Therefore, I can say the friction equals to the force. It is just starting to move. Therefore, we can say friction is equal to our force, right? Friction is equal to force, that is pull. Yes or no? But now the question is how practically you can measure it. What is the unit of friction? You guys know? How do you measure it? Very good. So friction is measured in Newton, right? How you will measure it? Okay, very good. With the help of the spring balance. What you guys do here? Let us say you connect the spring balance rather than just pulling the block here with the hand. So what is the advantage of that? It will show the reading of the force. You will connect the block with spring balance and then we will pull it. So we can measure the force or say friction in unit. So the reading of the spring balance, let us say for example, reading of the spring balance is 50 newtons. Okay, so there is the reading in 50 newtons. So what is the force here? Yes, of course, force equals to 50 newtons. You are not pulling it so fast, right? You are not pulling it fast. It is here just about to move. Just move. So, do you guys agree? The friction is equal to force. So, the friction will be 50 newtons. This is very smart and simple way of measuring the friction using the spring balance. So you can very much accurately, very much closely measure the friction. Simple experiment. So just to recap. So it is the measure of the friction of the force. Yes or no? Yes. Absolutely right. In this experiment, so the answer is yes. It is the friction measured. So, what is the unit we use? Newton. Very good. Very good. So, you guys respect Isaac Newton. But please write the Newton in smaller letter. Newton. Newton. For the full name. Or but if you write the abbreviation, it will be the capital letter N. When you are asked in exam, you write it with small letter. What does the capital name you talk about, right? Small n is Newton and capital letter N is the abbreviation. Unit names in physics is in small letters. The direction of the friction opposite to the force because there is no motion. Very good. So in this case you can write it like that, opposite to the force. Okay, it is easier to apply the force by one hand. Okay, don't break the chair or don't hurt yourself, but try this experiment. But if you apply force, it may not move. We will discuss in this next class. If the object is not moving, still there is a static friction. When the object is moving, there is a kinetic friction. Then you will understand the physics better because it is all about the physical things and not imagination. Right? Try it. So remember, what are the two types of forces? Force of contact or force of non-contact is called as the force of the distance. Because the friction in contact is must and you guys can visualize it and then discuss that. Right? We discussed that. Right? Irregularities of the two surfaces, they have to be in contact to each other. Okay? There has to be the physical contact. So there will be the friction. So definitely you guys write the answer is friction between the contact. Right? Contact is necessary. All of you agree with that? If you have any doubts, please ask. So, what happens when you rub your hands on the back of the patient? So, if you take your two hands and rub on the back of the patient like this, what happens? Patient's back becomes very warm. Heat is generated due to the friction, and the blood in veins starts circulating. Right? The back is getting warm. Why is it that? Very good. Definitely, if you feel when you rub the hands, their heat is generated and back becomes warm. What is the cause of that? Exactly. Very good. Friction produces heat. Right? Because two surfaces are rubbing to each other. Right? So this moment, right, when the two surfaces are rubbing, because of the friction, it is producing heat. Those guys are heating each other. Right? You can think, right, when your surfaces are rubbing to each other due to interlocking and heating each other. So definitely we can say the friction produces heat. Absolutely right. Friction is the cause of heat. Another example is when asteroid from other planets comes down on the earth, while coming down, it comes with contact Earth's atmospheric air, and there is tremendous friction between the atmospheric air and the asteroid. Ultimately causes tremendous heat. An asteroid burns its maximum portion and very small particles falls down. Thanks to the friction, which saves our Earth from a big damage. Here friction is helpful to us. Let me ask you another question, right? How you guys walk on the ice or snow? It was very difficult when we visited the Kashmir. We experienced that we were falling on the ground, right? It is really very difficult to walk. Fresh snow is still okay, but once the snow hardens, it is really dangerous. So very slippery. So you will have to be very careful on slippery surfaces. Okay? So why it is difficult to walk on ice? Please tell me. Yes, it is slippery. That is right. So why it is slippery? Why do you feel it slippery? Very good. So what is the answer? Because the friction is less. Excellent. You guys again gave the correct answer. Here it is because due to less friction. So guys, can you tell me friction is good or bad? What do you guys think? Friction is good or bad? You guys are diplomatic. You guys are telling both. Give the answer. Good or bad? You are absolutely right. Both. Right? Because you know the machine parts friction is bad, as it causes wear and tear. Right? But in this case, when you are walking on ice, you don't want friction because otherwise you will fall. So here friction is good. Right? It helps us to walk. If you walk there is the friction between us and the ice surface, right? If you roll a ball or move the book, there is a friction. If you are walking on too much slippery surfaces of water or marble, you can easily slip. It is very dangerous to walk on water or on granite surface. Very, very risky, right? So friction is good thing here. Friction helps us to walk. Similarly, so if you walk step and walk on banana peel, you will slip again. What is the answer here? Exactly. Madhav is saying there won't be the friction between the objects. Exactly. Because in this case, again the banana peel is smooth. Right? Smooth and slippery. So banana peel is smooth and slippery, and again the smooth and slippery surfaces, as we discussed, are causes of less friction. There is less friction between our foot and banana peels, and therefore we tend to slip just like on an ice. So therefore, yes, exactly. So friction here is good, which helps us to walk. So this is something we want to learn, these guys. So what did we learn? Friction. Very, very important. Remember, friction is a force that opposes the motion. Okay? So you can easily understand the definition in your book to understand the concept here. I have written it. Friction is a force. So if you ask the question, what is the friction? It is the force that opposes the motion. Right? And let us learn today that the friction is caused by the irregularities of the two surfaces which are in contact, and very important, it is because this irregularities causes interlocking. Can you see guys that irregularities interlocking these surfaces? There is the cause of friction. Even though the surfaces appear to be smooth, but still there are irregularities. Rough surfaces have greater friction. Do you agree guys? Yes. If the surface is rough, definitely it will have a greater friction. What is the reason of that? If I ask, what you will say? Rough surfaces has greater friction. So what is the big role of teeth? Can you guys tell me? Because there is more irregularities between the rough surfaces, right? Rough surfaces has more irregularities and more interlocking, and obviously in opposite direction. If the surfaces are smooth, it will have lesser friction, because greater friction means, as we discussed, there will be the more interlocking for the rough surfaces because there are more irregularities. So it is something what we did today. So hope the concept of friction is super clear to you. I hope you have enjoyed the class. Please do share it, subscribe it with other friends. Thanks a lot. Bye bye.